In the previous video, when building the AR4 MK3 robot, I was still using an Arduino Uno to control it manually with a joystick. In this video, I'll be using a Teensy 4.1, which is the controller that's actually meant to be used, so the robot can connect to the controller software on the computer. First, the additional parts I'm using are a Cat6 keystone jack, an Ethernet cable, and a 3D printed holder for the Teensy terminal so it can be mounted inside the box, as well as a punch-down tool to install the cable into the Cat6 keystone jack. Next, install the cable into the Cat6 keystone jack using the punch-down tool. Keep in mind, the Cat6 cable here isn't for Ethernet communication, it's for connecting the encoder if you plan to use additional axes. You can skip this step if you're not adding extra axes. After that, I attach the 3D printed Teensy holder to the terminal so I can secure it to the box with screws, keeping the Teensy firmly in place. Here's how it looks after the Teensy 4.1 is mounted inside the box. It's now securely in place. Next, install the 3-position double-row terminal block and connect it to the ground, 5 volts, and 3 volts pins. This way, any wires that need those voltages can be easily connected to this terminal block. For the cables at the bottom, group together the ones with the same voltage, like ground, 3 volts, and 5 volts, before connecting them to the terminal block. This helps keep things organized and avoids having too many individual wires going into the terminal block, making the wiring cleaner and easier to manage. Here's how it looks after all the cables are connected to the Teensy pins and the terminal block. When wiring the cables to the Teensy pins, be very careful and make sure each connection is correct, especially the encoder wires, so there are no mistakes with the motor connections. Next, connect the micro USB cable to the Teensy 4.1. Since I wasn't able to get a 90-degree USB keystone jack, I'm using a longer cable that goes directly to the computer. Also, connect the cable for the gripper. The gripper is controlled by an Arduino Uno, which I've already installed in the additional box. Make sure everything is wired correctly according to the manual and the wiring diagram, so you don't run into connection issues later. Also, keep in mind that for software version 6.1 and after, the dip switch settings are different. Make sure the dip switches are set correctly, this affects the microstepping, and getting it right is important for proper calibration and movement. Next, after uploading the code to both the Teensy and the Arduino Nano, open the controller software on your computer and connect to both devices. First, we'll set the COM port for the Teensy. You can check which port it's using in the device manager. Once you find it, enter that COM port in the configuration settings, and when everything is correct, you should see a system ready notification. Next, we'll test the encoders. Load the built-in encoder test, then click the play button. At the bottom of the screen, you'll see a list showing the encoder values for all motors. Make sure the motor power is turned off, then manually move each motor one by one. Check that the encoder value for that motor changes. This confirms the encoder is working properly and can be read correctly by the software. Next, we'll test the limit switches. Load the built-in limit switch test program, then click the play button. You'll see a list of all the limit switches for each motor displayed at the bottom of the screen. Press each limit switch manually. You should see the value change to 1 when the switch is pressed, and back to 0 when it's released. This confirms that the limit switch is working properly. Next, we'll add the COM port for the Arduino Nano. Check the device manager to see which COM port the Nano is connected to. Once you have the port number, enter it in the configuration settings. If everything is set correctly, you should see a log message that says communication started with Arduino Nano I/O board. Next, let's test the gripper. Go to the Inputs, Outputs section, and for servo 0, enter a value of 0, this will close the gripper. Enter a value of 70 to open the gripper. Click the button to test the gripper opening and closing. You can also adjust the value for the open position if you need the gripper to open wider or narrower. Thank you for watching. I hope this video was helpful for building your AR4 MK3 robot. Don't forget to like and subscribe, and see you in the next video.